Hi students, how are you all? Welcome to PW English. This is MB Sir Physics. Today we are going to discuss about electric charges and fields complete summary. Okay? Yes. So after watching this complete video, definitely your confidence level goes to the peak stage beta. Okay? Because you have finished this chapter in your institutions, colleges, right? Yes. So you may solve so many numerical from this chapter also, right? But now what exactly you have to remember from this chapter, I am going to cover this all the things in this video beta. Okay, right. So before starting the class, just open your book and pen and note down each and every point. Okay, here whatever the points I have taken, okay, all are the very important points, and if you learn this important point, definitely you're going to solve all the numericals. Okay, so whatever the formulas I have covered, it is sufficient, it is more than enough for solving the numericals beta. Okay, don't neglect the video and don't skip the video also. Okay, right beta. So 100% I'm giving guarantee for you that definitely you're going to enjoy the class, this one. Okay, right beta. So let us start then. So see here beta, today we are going to cover this all the topics. Okay, what is exactly electrostatics called, okay, types of charges, sharing of charge, quantization of charge. Okay, right. So next, law of conservation of charge, method by which a body gets charged. Next, Coulomb's inverse square law, force between multiple charges. So I am going to tell you the tricks also, which formula, where to apply, in which condition we have to apply that formula. Okay, so just listen carefully. Okay na? Right beta. Chalo. So next, what is electric field intensity? Electric field intensity due to multiple charges, electric field intensity due to finite and infinite rod. Okay, electric field intensity due to arc carrying charge Q. Okay, next, motion of charge in electric field, electric dipole and electric dipole moment. Okay, so electric field intensity due to dipole along the axial line. Next, electric field intensity due to dipole along equatorial line. Next, electric field intensity due to dipole at any point in space, torque acting on electric dipole kept in electric field. Okay, potential energy of electric dipole, electric flux. Okay, so complete chapter beta, really you will enjoy this one. Okay, and what is gas law also. Okay, right beta. So let us start then. Okay, all of you open your pen and book now. So what is electrostatics? Okay, yes, what is this one beta? The study of different properties of charges which are at rest is called as electrostatics. Okay, right beta. So see here, we know what is charge, right? We know that we have a two types of charges, sir. That is a positive and one is a negatively charged. Okay, so when charge is in rest position, okay, so how it is behaving, okay, what it is emitting. Okay, so we are learning about the different properties of charges which is in rest position. Okay, this is called as electrostatics beta. Okay, this study is called as electrostatics. In electrostatic, 100% the charge should be in rest. Okay, right beta. Now, so what is charge, sir? Charge is nothing but it is a property of matter which experience a force when it is placed in electromagnetic field. Am I right? Yes. So this is called as what? Charge. Okay, so for the board exam they won't ask you this definition, as well as, so this is not so helpful for you in NEET as well as in JEE as well as in board also. They won't ask you this one. Okay, right beta. So remember here, whatever the points I am covering here, each and every point is very important point. Okay, I will be mentioning you, okay, where to focus, okay, more. Okay, yes. Yes, beta. So let us start then. So electrostatics. What is mean by electrostatics? Okay, see here, beta. The study of different properties of charges which are at rest is called as electrostatics. Okay, so everyone know that the charge is of two types, na? Yes, one is a positively charged and one is a negatively charged. Okay, I'm taking the charge. Okay, that may be positive or negative, no problem. Okay, I'm taking a charge and I'm keeping on my hand. Okay, now it is in rest position, right? Correct. Now, when it is in rest position, what it is emitting, what is present in the surrounding. Okay, so we are going to discuss about the different properties of charges which are in rest. Okay, this study is called as what? Electrostatics, beta. Okay, right. Now, what is charge? It is a property of matter which experience a force when it is placed in electromagnetic field. Okay, this is called as what? Charge. Okay, now, so here everyone know that types of charges. Okay, what are they? One is a positively charged and one is a negatively charged, right, beta? Yes, correct. Note, okay, in a body, number of protons is equal to the number of electrons. Okay, in the universe, take any body in the universe, each and every body in the universe contains number of protons is equal to number of electrons. Okay, this point should be noted. Okay, this is a very important point. Okay, right, beta. So remember this one. Now, sir, each and every body in the universe is neutral. 100% it is neutral only. Why? Because in each and every body we have number of protons and number of electrons. Of course, after combination of this one, they will become neutral only. Right, beta? Yes, right. So, sir, then how a body gets charged? Correct? Sir, how we get a positively charged body then? How we get a negatively charged body then? Because in the universe we have each and every body is a neutral stage, right? So how we can make a positively charged body and a negatively charged body? Okay, this can be possible by using a rubbing, beta. If two bodies rub each other, then body get charged. Okay, that may be positive or it may be negative, depends upon the property of a material of a body, beta. Okay, right. Now see here, beta. See here I have noted down some negatively charged bodies and I have noted down some positively charged bodies, beta. Okay, so see here, what are the negatively charged bodies? Amber, plastic, embonnet rod, silk cloth. Okay, so these all always possess a negatively charged only. Okay, you have to remember this one, beta. Okay, right. So the first question is what? If each and every body in the universe is always neutral, then how we make a charged body? How we can make a charged body? How? By rubbing. Okay, see here, when body rub each other, okay, charge get shared down. When bodies rub each other, charge get shared down. I will tell you. Okay, now see here, beta. See here. So here are the positively charged bodies. They are the fur, glass rod, hair, and the woolen cloth. Okay. Now see here, beta. I am taking one example for you. Okay. So initially, these are the two bodies. Okay. I am taking this one as a ebonite rod. Okay. This as a ebonite rod, and this is a glass rod. Okay. This is a glass rod, and this is what? Ebonite rod. Okay. Now, initially they are what? Neutral. Okay, initially they are what? Neutral. Now when these two bodies rub each other, now they get charged. Now it has become the charged body, beta. Okay, this ebonite rod becomes the negatively charged and this becomes the positively charged, beta. Okay, right. So now this has become the negatively charged body now. When I keep this one upon my head, okay, what happens? All my hairs will be attracting towards this rod. Okay, sir, they are not attracting. So simply I am saying you, beta. Okay, generally See here, this is a negatively charged body now. Yes. Our hairs act as a fur. So see here, I have written here fur na. What this fur is called? Hairy like substance is called as fur. Okay. These are the hairs. Na? Hairs act as a positively charged. This one is what? Negatively charged. As everyone know that positive and negative will get attract. Na? So at that time, my hairs will be moving in a upward direction, beta. Okay, it will be attracting this one pen. Okay, is it clear? Is it clear for you all? Yes. Now see here, observe carefully. Once again, I'm explaining this one. So this is what? A bonnet rod, and this is what? Glass rod. Okay, this is what? A bonnet rod, and this is what? Glass rod. Now, initially they are neutral. Okay, initially they are what? Neutral. Okay, when these two are rubbed each other, now they got charged. Okay, right, beta. So this glass rod will become a positively charged body, and the ebonite rod will become the negatively charged body. Okay, right, beta. So when I keep this negatively charged body upon my hair, okay, upon my head, what happens? The hairs will attract towards this negatively charged body. Am I right? Yes. Now tell me. Okay, so now they are charged, na? Now what happens now? So wow. So now tell me, what is the answer now? Does these two are charged bodies? No. No, but again they become the neutral. Sir, how? I'll tell you. See here. Initially, how they are now? Neutral. Very good. Okay. What happens now? Sir, now they become the charged, right? Yes. This is what? Negatively charged. This is what? Positively charged. Okay. Now the hairs are attracting. Very good. Okay. Now what I am doing is, I am getting in contact with these two. Okay. I kept in a contact. Okay. Right. Now I am removing this one. Okay. Now when I keep this body upon my head, what happens? Does the hairs will attract? No. They will not attract, beta. When they are in contact, automatically they become the neutral. Okay. See here. Initially neutral. Now charge. Now neutral. Okay. Is it clear, beta? Now hairs are attracting? No. Because it is neutral. Now charged. Okay. Now neutral. Okay. Now see here. Now they are charged. Right. Now they are attracting. Right. Now I am releasing this one. Okay. I am releasing this one. Okay. It is coming and falling on the ground. Okay. Let us assume this is the ground. Okay. Now again I am taking this one. Again I am keeping on my head. What happens? Does my hair rises? No. Why? Because when the charged body is in contact with the ground, it becomes neutral. Is it clear? Right, beta. So it becomes neutral. That's why the hairs are not attracting towards the pen. Is it clear? Is it clear for you all? No doubts, na? Right, beta. Very good. So this doubt has been clear for you all, na? Now tell me. Now they are, sir, neutral. Very good. Now they are charged. Very good. Now they are again neutral. Very good. Now they are, sir, again they charged. Very good. So when it is falling on the ground, now it is neutral. Very good, beta. So these are the key points you have to remember. Okay, these are the key points you have to remember. Okay. Now see here. Amber, plastic rod, ebonite rod, and the silk cloth always become negatively charged, beta. Always become negatively charged. You have to remember this one 100%. Okay. I'll tell you the trick. Okay. I will tell you the trick. A for, see here, A for amber, P for plastic, E for ebonite, S for silk. Na? Apes. Remember apes. A-P-E-S. Okay. What is the meaning of apes? A monkey without tail. Okay. We only. Human beings. Chalo. So A for amber, P for plastic rod, okay, E for ebonite rod, S for silk cloth. Okay. If these are negatively charged, of course, another body will be opposite to that one. Na? They will become the positively charged. Is it clear, beta? Is it clear? Chalo. Now, so note point. See here. When positively charged body touches the ground, what happens? This is a very interesting question. Okay, see here, when positively charged body. Okay, see here. See here. This is what glass rod. This is what ebonite rod, right? Initially they are neutral. Now they got charged. No? Yes. So this is what positively charged body. When positively charged body touches the ground, what happens? Okay, when positively charged body touches the ground, what happens? It will become neutral. No? As everyone know that it will become neutral. Correct. So here you will get one doubt. Sir, this is a positively charged body, so it is falling on the ground, right? So let us assume that there are 100 protons inside this body, okay? Let us assume that there are 100 protons inside this one, okay? So when it is touching the ground, what happens now, okay? Does this 100 proton goes inside the earth, or else the 100 electrons from earth goes inside the rod? Yes, beta, which one is correct? The answer is 100 electrons from the ground will enter. Okay, 100 electrons from ground will enter into the rod and make it neutral. Okay, and makes it neutral, beta. Okay, see here. All electrons from ground enter into the body and makes it neutral. Okay, clear? Sir, you will get one doubt. Sir, why protons are not going inside that? Remember this one, only electrons are transferable. Remember, okay, these are the concept based questions you may get, okay, in your board or else in NEET exam also, okay, concept based question. Okay, they will be asking you the same thing. Okay, when positively charged body is in contact with the ground, what happens? Okay, in option they will be giving you. Okay, electron will be transferring from ground to body, or protons will be transferring from body to ground, like this, vice versa. Okay, chalo. So what you have to tell? Only electrons. Okay, only electrons are transferable, and the electrons from the ground will enter into the body and makes it neutral. Okay. Now see here, when negatively charged body touches the ground, just now I said you know, now they become the charged bodies, right? So the hairs are attracting, right? So now I am releasing. Okay, it is touching the ground. What happens? So it becomes a neutral, right? See here, when negatively charged, let us assume that there are 100 electrons inside this pen. Okay, now what happens when it touches the ground? The 100 electrons will enter into the ground and makes it neutral. Okay, and it becomes a neutral, beta. Okay, only electrons are transferable. Just remember this point. Okay, is it clear? Chalo. You see here, when negatively charged body touches the ground, all electron goes inside the earth and makes it neutral. Chalo. So note down. These are also very important point. Like charge repel each other, as everyone know that positive get repulsion, and negative also get repulsion. Na? Positive. Okay. So around a charge we have electric field lines. So these are called as what? Electric field line. For a positively charged, the electric field lines are always in outward direction. Okay. Right, beta. So for negatively charged, it will be in inward direction. Okay, unlike charges attract each other. See here, positive get repulsed, negative again it is getting repulsion. Okay, so electric field lines are inwards for negatively charged. For positive charge they are outwards. Na? Positive and negatively charged, they will attract. See here, for negative charge it is outwards, and for a positively charged it is outwards, for negative charge it is inwards. See here. Okay, so they are following the correct path, right? So finally they are attracting. Here they are repelling. Okay, chalo. Now this point to be noted, he may ask you directly. Okay, direct question. Here are the charges I am taking. Okay, when charge is in rest position, and when charge is in uniform motion, when charge is in non-uniform motion, what it emits? Okay, when charge is in rest position, it emits only electric field. What it emits? Only electric field, beta. Okay, right. So when charge is in uniform motion, what it emits? Electric field and magnetic field. Okay, see here, beta. Remember this, all the points. These are the key points I have taken. Okay, after finishing the class also do the revision of this one. Okay, most of the student will complete the chapter and goes to the next chapter. After finishing that chapter also again they go to the next chapter, but when they are in third chapter they will forget 2 chapters. Why? Because they won't do any revision beta. Okay, they don't know what exactly they have to learn. Okay, they don't know what exactly we have to learn from that chapter. Okay, so these are the key points you have to learn and you have to remember. Okay, this will be useful for your J mains, NEET as well as for the board also. Okay, when charge is in uniform motion, what it emits? Electric field and magnetic field. Remember this point. Okay, right beta. When charge is in non-uniform motion, what it emits? Electric field, magnetic field and radiation. Extra you will get radiation. When it is in rest, it only emits electric field. In uniform motion, it emits electric and magnetic field also. In non-uniform motion, it emits electric field, magnetic field and radiation beta. Okay, see here, these all points are noted. Okay, to make positively charged body, we have to remove electrons. If you remove the electron from a body, each and every body in the universe is neutral, correct? To make it positive charge, we have to remove the electrons. Khatam. It becomes a positive charge. To make negatively charged, what we have to do? We have to add some more electrons, because electrons are movable, transferable. I said you know, not protons, only electrons are transferable. Okay. To make negatively charged body, we have to add the electrons. Okay, is it clear? If you add more electrons, of course the concentration of electrons will be more. It becomes a negatively charged body. Charge is what? Scalar quantity. Remember, SI units, Coulomb, CGS, ESU or Franklin we can call. Dimension formula is this one. Okay, I is equal to Q by T, right? I is equal to Q by T. So Q equal to I T. So T for time, I for current. Okay, so for current we used to write in amperes. No? Just remember this one. Okay. Now sharing of charge. How does a charge get shared? Sir, when we rub each other, body gets charge gets shared. Na? Now one more method we have. See here, charge associated with mass. Does the charge associated with the mass? Yes. Mass of positively charged body is very low. Why? Because we are removing the electrons now. As we are removing the electron from a body, then only it becomes a negatively charged. When we remove the electrons from a body, it becomes the positively charged, right? Yes, so the concentration of positive charge is very low. Of course, mass will be very low. Okay, mass of negative charge is what? High. Why? Because we are adding the electrons, right beta? Yes, so the concentration of electrons are more. Of course, the mass will be more. Chalo. So sharing of charge. So remember this one. When charged bodies are in contact, then charge get shared down. Okay, if two bodies are in contact, 100% charge get shared down. What is that shared down formula? Q1 plus Q2 by 2. See here. So I am taking this is a charge. Let us assume 100 protons here. Okay, and 50 electrons on this charge body. Okay, on this body. When these two are in contact and removed, okay, make them in contact and just separate them. What happened? What is the charge shared down in two bodies? What is the formula here? Q1 plus Q2 by 2. No? Yes. So 100 protons plus 50 electrons divided by 2. 100 proton plus 50 electron. 50 protons get neutral. So what is left? 50 protons are left. So finally becomes 25 protons. Okay. When these two bodies are in contact and separated, at that time the final charge on two bodies are 25 protons, and on this one also 25 protons. Okay, both become positive charge only. Okay, is it clear? I hope you have solved so many numericals on this one. Na? So I can't explain each and every numerical here. Just I am focusing the key points itself beta. I hope you have understand my concern. Okay. Yes. Quantization of charge. So what this exactly is? Okay. Can anyone tell me what is the charge present inside this pen? I said you know, each and every body in the universe contains some charge. contain some fixed charge. Okay, small bodies have a small charge, big bodies, okay, larger bodies have a heavy charge, but neutral only, no problem. Okay. Is it clear? Yes. Pen has, pen is a smaller object, it has a less amount of charge, correct? Book, somewhat bigger, so it has some more charge. Okay, now take this one, screen board. It is very bigger in size, right? And have a large mass also. Of course, the charge is also more inside that one, but the charge is fixed. Okay, but the charge is fixed. Can anyone tell me how much charge is present inside the pen? Sir, we can't tell. Sir, there are so many crores of charges are present inside this one, right? Am I right? Yes, you are right. But I want exactly how you can find out. So I can't explain the numerical beta. We have a numerical based on this one also. Okay. So see here, I am calculating the weight. Okay, weight of this pen. So let us assume that the mass of this pen is 10 grams. Okay, the mass of this pen is 10 grams, and it is made up of some. Okay, some chemical formula I have given. Okay, based on that chemicals we have made that one. Chemical formula I am giving to you. Okay. Right, beta. So what is the charge present inside that pen? In this pen, exactly we can calculate that one. But I can't explain that all the numerical for you because this is a summary na beta. So here I can cover only the key points for you. I can't cover all the things for you. Okay. So I hope you have learned this all the things in your institution classes or YouTube's, right? Okay. So please understand beta. So I can cover only the few points here because this is a summary series. Okay. If I complete each and if I explain you each and every point clearly, detailedly, it goes very long video. Okay, and it goes very lengthy also. So to complete this chapter, it nearly takes about 16 hours beta. Okay, to complete this chapter, it takes nearly 16 hours. So I can't finish this one. Okay. So just I can cover this one. I can cover only the key points for you. Okay. I hope you have understand beta. Chalo. So without wasting any time, let us continue this one. Chalo. So see here beta. What exactly this quantization of charge? Each and every body has a fixed charge. Okay. This one also fixed charge. Okay. So see here, I am giving you the 10 grams of water for you. Can you tell me the charge present inside the water? 10 grams of water, exactly you can find out that one. Okay, you have a numericals on that one, you can solve. Is it clear? Now I am giving you the 10 grams of gold for you. Can you find out the exactly charge present inside that one? 100% you can calculate. Okay, right. So see here, so what this quantization of charge tells you? How much charge is present inside the body. Okay, what is the charge present inside this body? What is the charge present? Exactly charge I want. What is the exact charge present inside this body? Okay, right. So if you take a physics book also, what is the exact charge present inside that one? We can find out. We have some numericals also based on this one. Okay, but I can't explain this one. So see here, every body in the universe contains a fixed charge in it, and this charge always remains constant. Okay, to calculate this one, you have to use this formula. The total charge present inside the body is what? Plus or minus Ne. Okay, plus Ne indicate the protons, minus Ne indicate the electrons. Is it clear? N value will be 1, 2, 3, 4, 5 like this. Okay, integer, but not like this. Okay, 1.5, 3.2, like in points we don't get. In decimals you won't get beta. Okay, right. So everybody in the universe always neutral. What is the net charge? Neutral, of course. Neutral is nothing but 0 only. Okay, remember this one. In exam, he will ask you what is the charge present inside the body. He will not ask you what is the net charge present inside the body. If he asks the net charge, directly you can write down the 0. Because number of protons is equal to number of electrons, right? In any body, correct? So net charge always becomes 0. Is it clear? In every body, net charge becomes 0 beta. Right. He will ask you what is the charge. Okay. So after putting this formula, you get some answer, right? So you got some like 100 protons present inside this one. Okay, he is asking how many electrons are present inside this body. You have to tell 100 electrons. Okay, he is asking how many protons are present. 100 protons. If you ask the electrons, okay, 100 electrons, you have to write down the 100. If you ask the protons, 100 protons, because this is neutral na beta. Okay, whatever he may ask you, if you ask the protons, write down 100 protons. If you ask the electrons, write down the 100 electrons. Okay, is it clear beta? Don't write, sir, in this one we have 100 protons and 98 electrons we have. Don't write like this. That is a wrong answer. Okay, because each and every body is neutral and 100% electrons and protons are neutral beta. Okay, so remember this all things. Charge of electron is this one, charge of proton is this one, mass of electron, mass of proton. Okay, right beta. So Q net, if you write plus Na, okay, so calculate the proton present in 10 grams of water. Calculate the protons. Okay, it means calculate the charge present in 10 grams of water. Okay, so you have to write down the plus. You will answer, you will be getting in a plus. Okay, plus something into something. Okay, some number you will get. Calculate the electrons in 10 grams of water. So just change the symbol, that's it. Okay, same question, you have to calculate the electrons now. Just put minus symbol here, that's it. If you put minus symbol, it gives the concentration of electron present in that water. Is it clear? If you write the positive symbol, it indicates the number of proton present inside that water. Okay, that's it beta. Just plus and minus signs changes. Okay, note, in exam he will ask you how much charge is present in a body. He will never ask you how much net charge present in a body. Okay, so in 1 gram of any substance contain Avogadro number of atoms beta. So just only one point I am writing here. Okay, right. So based on this one, you have to solve that one. Okay, chal. So let us go. Law of conservation of charge. Okay, as everyone know that charge can be neither created nor destroyed, but it can transfer from one body to another body, right? Here, only electrons are transferable, correct? See here, I am taking a positively charged, I am taking a glass rod. Okay, right. So as everyone know that APES, APES, sir, plastic is nothing but it becomes the negatively charged, sir. Very good, it becomes a negative only. Okay. Initially, let us assume that 100 protons and 100 electrons are present inside this one. Okay. Now, in glass rod also 100 protons and 100 electrons. Let us assume. It is also neutral. Initially, what is the net charge? Of course, neutral, sir. Here also, net charge, of course, neutral only. Am I right? Correct. This is before rubbing. Okay. Now, after rubbing, okay. After rubbing, what happens? Charge gets shed down. Okay. Now, this is what in the beginning we have taken the ebonite rod. Na? So now take this one as a plastic rod. Okay. This is a plastic and this is a glass. Okay. Glass becomes positive. This becomes negative. It means what? This is becoming negative charge. It means what? Electrons are transferred from this body to this body beta. I said you know, only electrons are transferable, not protons are transferred, right? So what happened in this process? Okay, what happens if we rub bodies each other? In that case, what happens? 100 electrons. Here, I will write here. During rubbing, okay. This is what our glass rod, no? This is what glass. Okay, this is what plastic rod. Okay, right beta. So what happens now? From a glass rod, 100 electrons will be shifting toward the plastic rod. Okay, from a glass rod, 100 electron will be shifting. Okay, so in the beginning, okay, so what is the charge present here? Sir, in the beginning we have a 100 protons, 100 electrons. During rubbing, 100 electrons are transferring from glass. glass rod to plastic rod, right? So 100 electrons are getting extra, na? So this become neutral. So finally, what is the charge present on this one plastic rod is 100 electrons, okay? 100 electrons are shifting inside this one. What is left? 100 protons are left. What is the final? Well, how many protons are left in glass rod? 100 protons are left. Is it clear, beta? Is it clear? 100 electrons from the glass rod are shifting to the plastic rod, okay? So he may ask you this one also, concept based question, okay? So when bodies are rubbed each other, okay, when a glass rod and a plastic rod rub each other, okay, does not does. So when these two bodies rub each other, from where to where electrons are transferring, okay? The charge is shifting from this body or to this body, from this body or to this body. He may ask you like this, beta. Okay, you have to tell like this. Is it clear? Only electrons are transferable. Okay, if plastic rod becomes negative, it means what? So the from glass rod, 100 electrons are shifting to the plastic rod. Like this, you have to tell, beta. Is it clear? I hope you got this one. Na? So I have explained this all the topics detailedly for you. But okay, so the coming topics I have to go faster, beta. Is it clear? Because I used to cover. So in a class, in a regular classes, we used to explain this one in a detailed way, in a depth way also, but I don't have that much time to explain. I'm just concentrating on the key points itself, beta. Okay. Methods by which a body gets charged. So one is due to friction. Friction is nothing but what? Rubbing. So as we learned in the beginning of the class, right? So this is what we have taken the glass rod, right? This is what ebonite rod, na? So initially they are neutral, okay? So now they become charged, okay? The hairs are attracting, right? Now they become neutral. Now the hairs are not attracting, okay? Now they become charged, okay? When I leave this one, when it touches the ground, now the hairs are not attracting. Why? It is becoming neutral. Is it clear? What happens here? All the electrons from this body, this is a negative charge body, na? All the electrons from this body is shifting towards the ground. Is it clear? The concept based question he may ask you here, okay? So as we have finished this one, okay? See here, beta, you can rub this one, okay? So ebonite rod and the fur. See here, this is what ebonite rod and this is the fur. So like this I can rub, okay? Again they become the charge only, okay? You can rub with anyone also, okay? Hair, fur, okay, woolen cloth. So you can rub this with the glass rod also, this plastic and this one also, amber and woolen cloth also. You can do. Is it clear? You can rub with anyone. Chalo, next, conduction. Okay, due to the conduction also we can make a charged bodies. How? See here. So here the trick is contact, beta. Conduction is nothing but what? Contact. So I am taking a source charge here. Let us assume that there are 100 protons inside this one, okay? Inside the source charge. This is what? Uncharged body, okay? There is no charge at all. Is it clear? No charge at all. Now, when a source body is kept in contact, 100% there should be a contact, okay? 100% there should be in contact, okay? When they are in contact, I said to you in the beginning, okay, charge gets shared down, na? So when charge bodies, okay, when charge bodies are getting contact, charge gets shared down. What is the charge shares formula? Q1 plus Q2 by 2, 100 protons plus 0 by 2. So finally what you got? 50 protons, right? Yes or no? So after putting this one in contact, just remove this one. Okay, what is the final charge now? This uncharged body became the charged body. Okay, this is the source charge. And the source charge, what is the charge left? What is the final charge left? 50 protons, and this one also become the 50 protons. Is it clear? When the bodies are in contact, definitely they will get charge. What is the sharing of charge formula? This one. Okay, this is what? Conduction. Next one is the induction. Okay, due to induction, not in contact. This is a trick for you. Okay, this is a source charge I am taking. In the step 1, what I have done is, okay, so let us assume that there are 100 protons on the source charge. this is uncharged body. These two are separated by a large distance, okay, in the step 1. Okay, in the step 2, I'll bring these two bodies closer. Okay, right beta? So here we have a 100 protons. Am I right? Yes, sir. Okay. Now, this is an uncharged body. Yes, correct. So, protons and electrons both are equal. Correct? Yes. Now, see here, there are 100 protons. Na? So, the 100 electrons comes and crowded here. These are what? 100 electrons. 100 electrons. So, in this one, we have 100 protons also, right? Because these are neutral now. 100 protons and 100 electrons. Positively charged, get repulsed, right? So, the protons will be crowded here. Is it clear, beta? 100 protons will be crowded here. Is it clear? Chal. So, finally, here we have 100 protons, correct? Chal. Now, how to become this one as a charged body without contact? I'll show you. Is it clear? Chal. So, positive charge is going here, plus repulse. Negative charge is negative and positive charge get attracted because negative charge will be crowding here itself, right? Now, keep this one as it is like this, okay? What I'm doing is, I'm taking a wire and keeping it to the ground, okay? Attaching to the grounds, okay? So, here we have on the source charge, we have 100 protons, correct? So, here we have electrons, right? So, electrons are crowded here. Now, how many electrons do you have? 100 electrons, correct? So, here. So, how many protons we have here? 100 protons, correct? Yes. Now, when you keep a wire to the ground, when you attach a wire to the ground, what happens now? Here are the protons, right? So, from the ground, okay, when it is grounded, this is symbol of grounded, beta, okay? Now, 100 electrons from the ground will enter to this wire, okay? Only electrons are transferable, I said, you know, because these are the 100 electrons will be, these electrons are attracted by this one, right? Because they are not movable, okay? From the 100 electrons from the ground, from the wire, they will be entering and make it neutral. Is it clear? So, this 100 electrons, 100 protons get balanced. Okay, it becomes a neutral. So, finally, in the next, so finally, what you got, beta? So, these are what? 100 proton and 100 electrons are crowded here. Na? Correct, 100 electrons are crowded here. So, finally, it is become the charged body. Na? Yes, so finally, what I am doing is, I am keeping, okay, I am catching this one and I am separating these two. Okay, I am separating these two now. In the next step, okay, I have separated this one. So finally, what happened, beta? So when I have separated this one, the charge will be equally distributed on its surface. Is it clear? Yes or no? So finally, this becomes the negatively charged body, and this is a source charge. Okay, this is what? 100 protons. Is it clear? A uncharged body without touching that one, we made it as a charged body. Am I right? Chalo. So, making two charged bodies at once. How we can make two charged bodies at once? Okay. The same manner I'm taking here. Okay. So 100 protons here. Okay. They are the neutral charge. Okay. Uncharged bodies. Okay. But these two are in contact right now. Okay. These two are separated. Okay. Now I'm bringing closer to them. Okay. Now see here, beta. 100 protons are present here. Correct? Correct, sir. Now, so 100 protons are here. Then, of course, 100 electrons will be crowded here, right? 100 electrons will be crowded here. 100 protons will be crowded here, right? Because positive charge get repulse. Am I right? Khatam. They become the charge body, beta. Now, no need to giving connection to the ground. Okay, you can give your wish. Okay, but I'm not giving here. What I'm doing is I'm catching this one and pulling this in this direction. Okay, I'm separating this one. Okay, I'm keeping here. So finally it becomes what? Positively charged body. Yes or no? Correct? Yes, so it is becoming a positively charged body. How many protons it have? 100 protons. Yes, correct. This is our source charge. Am I right? This is 100 protons, right? So here we have a 100 electrons. No? These are crowded. Why? Because the source charge is here itself. All are attracting here. Okay. When I separate these two now, what happens? This negative charge will be distributed uniformly on the sphere, right? Correct. So finally it is becoming a negatively charged body. That is a positively charged body. In the beginning only we have done. Correct. This is a positively charged. 100 protons. This is a negatively charged. And this is our source charge. Correct. 100 protons. So without touching also, we made a positively and negatively charged body at once. Okay. Concept based questions he may ask you. Okay. Next one is a Coulomb's inverse square law. Very, very, very important beta. Okay. So I hope you have solved so many numericals on this one. Okay. So very, very, very important. Okay. So there is one best trick to solve all the numericals. I will tell you the trick also. Okay, I don't know in which method your teacher taught you. Okay, I have a best trick to solve the numericals also. Okay, if you find anywhere, so you can go through there. But so I don't know exactly in which method you have learned and in which method you are solving the numericals on Coulomb's inverse square law. Okay. The thing is, this is one is very important beta. Okay. Force never becomes zero in the universe. Okay. Remember this one. Force will never become zero in the universe. As everyone know that this is a positively charged, this is a positively charged, this is a charge Q1, this is a charge Q2. Okay. Of course, positive, positive get repulsed now. Yes. So what this charge will do? Okay. This charge will push this charge in this direction with a force F2. Okay. The force acting on a second charge is what? F2. Okay, due to the first charge, what this charge will do? This charge will also push this charge in this direction, right? Yes, with how much force it is pushing? With F1 force due to the second charge. Okay, this F12 and F21, you know this one, na? Yes, main formula, remember. Okay, so I can't explain you this one detailedly. You know what? To explain Coulomb's inverse square law, okay, I can explain this one for you. Nearly about 2 hours. 2 hours I can explain this just for one formula. Okay, but right now I don't have time to explain this all the things. Just I am telling you the key point. Just learn the formula right now. Okay, right. So I can't explain you detailedly beta. I hope you understand. Force is directly proportional to product of their charges and inversely proportional to squares of the distance separated by them. The distance separated by them is smaller. Okay, so finally we can write down like this. If we remove the proportionality constant, we get some constant k. This k is 1 by 4 pi epsilon naught and the value is this one beta. Okay, so epsilon naught is nothing but permittivity of free space. Its value is this one. Okay, so force value. So final formula what we got? 1 by 4 pi epsilon naught q1 q2 by r square. Okay, or else you can write down like this also. Okay, k value you can put down this one also. Is it clear? This is the main formula for you. Remember. Okay, I can't explain you the derivation part in the explanation parts. Okay, right, but I can tell you these are the important points. But if you remember, it is sufficient. It is sufficient also. Okay, whatever the points I am telling to you now, these are sufficient for the JEE mains as well as for the NEET also, and addition to this one for the board also it is sufficient. Okay, note, gravitational force doesn't depends upon the medium, but the Coulomb force depends upon the medium beta. Remember this one. Okay, now so relative permittivity, it is denoted by symbol K. So the formula for this one is the ratio of permittivity of medium by permittivity of free space. M indicates medium, O indicates the free space. Okay, K is this one. Okay, so we can solve the relative permittivity in terms of force, relative permittivity in terms of force. This one you have to remember beta. Okay, K is equal to F0 by Fm. So actually we have a proof also, but it is not needed. Okay, it is not at all useful for you also. Okay, F naught by Fm. So this one you have to remember. Okay, in exam he will give the K value. Okay, he will give the K value and he will give you the force in free space. You have to find out this one. He may give this one and this one. You have to calculate this one. Okay, any two of them he will be giving you and one of them you have to calculate beta. Okay, this is important. And how to remember this one I will tell you. Okay, so F naught by Fm. Sir, how to remember? In the numerator it is free space and the denominator it is medium, right? Remember ohm, 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 ohm. Okay, remember this one beta. Okay, so for metals K value is infinite, just remember that one. Now Coulomb's force is applicable for, okay, this formula is applicable. See here, where for 2 point charges Q1, Q2 and this one, and 2 spherical bodies Q1, Q2, the distance separated by them is always taken from the center only, remember. Okay, the distance separated by these two charges is always taken from the center of the spheres. Okay, and this formula is applicable for the one spherical body and one is a point charge. Okay, now Coulomb's force is not applicable here. Coulomb's force is not applicable. Okay, so this is a charge body I am taking. The charge on this one is Q1. Okay, a rod having a length L, having a charge Q1, and a point charge I am taking Q2. From here to here distance A, and the length of this one is this one. What is the force between these two? Coulomb's force is not applicable here. Okay, here direct formula is not applicable here, so we have to do the integration here. So no need of doing any integration, no need of any solving. Just remember the trick. Direct question. K Q1 Q2 by R square, right? So here R is nothing but this distance and from here to here distance. A in bracket L plus L. Okay? Remember the trick. No need of solving. Force between multiple charges. Okay? Force between multiple charges. These are the very infinite times important beta. Okay, so however he give you the numerical, definitely you are going to solve this one. Okay, you know what, one question he may ask you. See here, Q, three charges are present. You have to find out the net force on this one. Okay, these three charges are kept at 3 vertices of an equilateral triangle having a side A. Find the force on this one. Okay, see here, he may ask you this question in 6 to 7 ways. Okay, so I taught this one in a regular class, but I can't explain you here beta. Okay, in one question, okay, this is the question, but he will be asking you in a 7 ways. Okay, but if you learn this trick, if you remember this one, those who watch my videos and those who watch my style of teaching, of course they can solve this one numerical very easily beta. Okay, but I don't know, so different teacher used to explain this one in a different styles. Okay, so I have a different style also to explain this one. I will be explaining based on this trick only. Okay, that's why I have written all the formulas here. Okay, you can solve this one. Okay, based on my method, you can solve this one in just in 20 seconds. You can finish this one in 20 seconds. Okay. However, he may ask you the question in 7 ways. He will be asking you in 7 ways. Maximum within 35 to 40 seconds you can close this one. Okay, most of the students don't know how to solve this type of numericals. So like this, charges Q, and Q is here. They are placed on, okay, 4 corners of a square. Find the net force on here. Find the net force on here. Okay, if it is in center, of course it will be 0 only, no problem. Okay, you have to find out this one. Okay, so you can solve this one within less than 40 seconds only beta. Okay, so let it be. So if you learn this one, okay, you can solve this one, each and every numerical, this type of questions in less than 40 seconds beta. Okay, the net force acting on a charge small q. Okay, so as everyone know this one, na? Net to force formula. See here, beta, write down this one. Okay, as everyone know this diagram also, na? Okay, so this is small q, here is a q1, q2, q3, like this you have, na beta, as see here, one more important point while solving the numericals. See is what? Okay, so in exam, if we ask find the net force on this charge, it means that this charge is movable. Okay, this charge is movable. Rest of the charges are fixed charges. This is a very, very, very important point. If you forgot this one, of course, you can't solve at least one question also. Okay, based on this topic. Okay. Chalo, so I hope you have solved so many numericals, na? Chalo, so let us go forward then. Very important formulas, okay? See here, so the net force on this one is what? The force due to this one. This is positive, this is positive. What this charge is doing? It is pushing this charge in this direction, okay? The distance from this one is R2, okay? What this charging is doing? This charge is pushing this charge in this direction. Because positive, get repel na. Chalo. So finally the net force will be like this, beta. If theta is present and F1 and F2 are present, okay, so like this. This is a F1 and this is what? F2. Angle between them is F. What is the net force? What is the net force? Under root of F1 square plus F2 square plus 2 F1 F2 cos theta. Okay, most of the students used to solve based on this formula, but I won't use this formula while solving the numerical. I won't use this one. Okay, but most of the students used to do. Okay, if the question is very easy, you can do it. But he may, if he asks you the direction, what happens? You are unable to solve that one, right? And if you ask what is the net force in x-axis, you are unable to do. What is the net force in y-axis? You are unable to do. Only you are able to solve when the net force, what is the magnitude of net force, you are able to solve. But x-axis, y-axis, direction, you are unable to solve this, all the things, okay? But I won't use this, maximally I won't use this formula, okay? But some students will use, based on this one also, you are able to solve, but it takes lot of time. Chalo, if theta equals 0, if forces are same, okay, if theta is 0 and the forces are same, then net force become 2F. If theta equal 30 degrees and F1 equal to F2 equal to F, then net force become root 2 plus 3 into F. Remember this all formulas, beta. Then only I am giving guarantee for you. You are able to solve the numericals, this type of numericals in 40 seconds. Okay. But if you remember this one only. Okay. If theta equal 45 degrees, then forces are same. Then net force become root 2 plus root 2 into F. If theta equals 60 degrees, then net force become root 3F. If theta equals 90 degrees, okay, forces are same. If the forces are different, we use this one. If the forces are same, remember this one. Okay, if theta equals 120 degrees, net force become F. If theta equals 180 degrees, net force become, if there are different forces, F1 minus F2. If they are same, of course 0. Okay. Now, electric field intensity. E is equal to KQ by R square. Okay. Electric field intensity. K is nothing but, as everyone know, na? So it is what? 1 by 4 pi epsilon naught only. Okay. Electric field intensity in terms of relative permittivity. Okay. Again, the same thing. Ohm. This is in terms of force and this is in terms of electric field. Okay. Remember the trick. That is a ohm. Okay. Note. While solving the electric field intensity in numerical, 100% charge will not present at that point, but in force 100% charge will be present. See here, Q, Q, Q. So he will ask you, what is the force on this charge? Force. Now, while solving the electric field intensity numericals, there will be no charge here. What is the electric field intensity at this point? He will ask you. Okay, at that point charge will be not present. Okay, chalo beta. So that is the main point you have to remember. Okay, the net electric field acting on a charge small q. The same thing, whatever I have written for the forces, same copy paste, just have removed the symbol F and have inserted the symbol capital E. Okay, is it clear beta? The same concept, copy paste concept. Okay, for electric field numerical, we're solving the electric field numericals and the Coulomb's force numericals. Okay, same model you'll be getting. Okay, copy paste, note down this one and remember this one. Okay, electric field intensity due to arc having a charge q. See here, this one it goes very tough for you, na? Correct? So I have taken my hair. Okay. So let us assume that there is a lot of charge in my pocket. Okay. So what I'm doing is I'm taking this hair and keeping my this one in my pocket. Okay. I'm disturbing it very a lot. Okay. So finally the charge is present on this one also, right? Right, beta? So what I'm doing is I'm inserting this charge on the board. Okay. I'm throwing this one charge on the board. So finally it falls like this. Right, beta? Am I right? Yes, correct. So when it falls like this, the charge on this one is, let us assume Q. It is making some angle theta having a radius r. So you have to find out the electric field intensity due to this arc having a charge Q and radius r at this point. How you can calculate? Okay, how we can calculate? Sir, to solve this one, it take lot of time, sir, and it is very irritating also for you. Huh? I will tell you the best trick. Within seconds, you can solve this one, beta. Okay. Yes. So the best trick for this one is, so in exam, he may give you the angle is 60 degrees, 90 degrees, 120, 270, 360, 330, 320, something angle he will give you. But solving this one is very easy. What you have to do is, what you have to remember is, you have to remember this one. Electric field intensity along the x-axis. K lambda by r integration of theta 1 to theta 2 cos theta d theta, and along the y-axis K lambda by r integration of theta 1 to theta 2 sin theta d theta beta. Okay, if it is 60 degrees here to here, okay, keep the limits 0 to 60, 0 to 60. Solve this one. You'll get along x-axis. Next you will get along y-axis. Khatam. This is what? Net electric field intensity. Okay, next do the magnitude, you will get the final answer. That's it. Is it clear? Is it clear, beta? Khatam. You got. Okay. Chalo. So, if he ask you the electric field intensity from theta values, different values, okay, from 30 degrees to 60 degrees. So, 30 to 60, 30 to 60, just put it these values in a theta, okay, in place of theta, and solve this one. Again, you will get like this. Again, do the magnitude. That is the final answer. Is it clear, beta? What is lambda here? Okay, what is the lambda? Linear charge density. Total charge by total length. The length of this one. Okay. Small charge by small length. Is it clear? Total charge by total length. Small charge by small length. Okay. Is it clear, beta? So, he may give you 60 degree, 30 degree, 45 degree. Whatever the angle he may give, just put on this one here and solve this one. You will get the final answer. This is the best trick. Remember the formula. Electric field intensity due to finite charge wire. Okay. See here, beta. This is a finite charge wire. So what I am doing is, I am taking my hair. I am doing like this, like this, like this, like this, like this, like this. I am making it finally it become the straight. Let us assume. Okay. Finally it become the straight. Okay. So in my pocket, there's a lot of charge present inside that one. Okay. So finally, what I'm doing, I'm just inserting that one. Okay. I'm doing like this, like this, like this. So finally, the charge is present on this one. Right. Next, I am throwing here. So finally, this is the wire having a charge on this one. Right. Let the charge on this one is Q. Okay. You have to calculate the electric field intensity due to this wire at this point. Okay. Which is at a distance of small r. Okay, remember this one. This is very important. This should be 100% perpendicular distance. If you forget this one, khatam. Okay, you are unable to solve the numericals. Okay, this should be perpendicular distance, beta. Okay, and next what you have to do is, you have to stand here. Okay, So you have to stand here. Okay, so you have to look at the topmost point. Okay, it makes some angle, na? Alpha. That is a noted down. It has a alpha. Okay, now look at the bottom point. Okay, so it is making some angle, na? Okay, so it becomes a beta. Okay, the alpha and beta values. So see here, the alpha and beta values. So see here, like this you have to take. From perpendicular distance, so you have to go up. From the perpendicular distance, you have to go down for the beta value. Okay, remember this one and remember this formula also. Along the x-axis, this is a formula. Along the y-axis, this is a formula. In question, he will give you the alpha and beta values. Okay, alpha and beta value. This is a finite wire. Is it clear? Is it clear? Chalo. Next, electric field intensity due to infinite charge wire. Infinite wire. Okay. Now same here. So he will ask you what is electric field intensity at this point, which is at a distance of smaller from this infinite wire. This R should be 100% perpendicular distance. Okay. Right, beta. So see here, alpha value and beta value. How to calculate? So just now I said you that if it is a finite wire, sir, we have to look at the top. Na? Now this is what? Infinite wire. So for infinite wire, look at the top corner wala. So we have to look like this. Oh my God. Right? So you have to look like this. Correct? Okay, so finally it is becoming. Okay, see here, finally it is becoming. So you have to look in the sky, right? So the angle is what? 90 degrees. Okay, and for bottom also. Okay, look at this corner. So like this we have to look. Correct? So beta value becomes also 90 degrees. Okay, alpha and beta value 90 degrees. Just put down in this formula. Okay, just now we have learned this formula. Na? Just put down here. Okay, so this is 90, this is 90, sin 90 is 1, 1 plus 1, 2. Finally 2k lambda by r we got. Okay, this is 90 and this is 90. Cos 90 is what? 0. So finally along the y-axis we don't have, only x-axis. Only along the x-axis we have. Okay. Electric field intensity due to infinite charge sheet. Infinite charge sheet. So finally what we get is sigma by 2 epsilon naught. Okay. Sigma is nothing but what? See here, 1 dimension, 2 dimension and a 3 dimension. We have a charge distribution. Okay. 1 dimension is nothing but my hair. So here we call it as a linear charge density. What we call? Linear charge density denoted by symbol lambda. The formula for this one is total charge by total length, small charge by small length. Is it clear? Chalo. For the 2 dimension, it is a paper. Okay, paper. Take a paper. Okay, and distribute a charge on it. Okay, completely up and down also. Okay, right. So here we indicate by the sigma, and this is called as a aerial charge density. Aerial charge density. Total charge by total area, small charge by small area. Okay. Next, for the 3D. 3D is nothing but laddu. Okay. Gulab jam. Everyone know na? That one. Sphere, beta, solid spheres. Iron ball. Okay. Iron solid ball. Okay. So there we used to indicate by a symbol rho, and this is called as a volume charge density. What it is called? Volume charge density. Formula is total charge by total volume, small charge by small volume. Is it clear? Is it clear for you all, beta? Okay, right. So see here, this is a like one type of paper, na? This is a infinite. Okay, infinite paper charge sheet I have taken here. Okay, due to this one, the electric field intensity we get is this one, sigma by 2 epsilon naught. Remember one point. Electric field intensity will never decreases with the distance. Here, is there any smaller distance? As the electric field travels in a forward direction, it goes with a constant electric field intensity. But it doesn't depend upon the smaller value. Okay, distance. Remember. Okay. Chalo. Next, electric field intensity due to uniform circular charge sheet. Okay, circular charge sheet. So just remember this formula, beta. Okay. Next, electric field intensity due to uniform circular wire on axis. Okay, this is a charged wire. Take a bangle. Okay, I am taking a bangle. I am keeping in my pocket like this, like this, like this. I am doing like this. because the charge is filled. Okay, I have bought so much of charge in my pocket. Okay, like this, I filled it. Okay, I have taken this one, I have kept here. Is it clear, beta? So like this. Okay, on the axis is nothing but this one. Okay, so you have to calculate the electric field intensity on the axis. On the axis here. Okay, at this point you have to calculate. What is the formula? Just remember, kq small r by capital R square plus small r square whole power 3 by 2. Okay, remember this one. This is what small r. This is what radius of the circle. Okay, here what you'll get plus na from Pythagoras theorem, capital R square plus small r square. Okay, right, beta? So maximum electric field intensity on the axis. Okay, we will be getting the maximum electric field intensity on the somewhere at a distance on the axis. Okay, so at which distance we will get the maximum electric field intensity? At a distance of plus or minus r by 2, we get a maximum electric field intensity on the axis. What is that maximum value? 2 by 3 root 3 kq by r square. Okay, remember this one. Remember. Okay, so how does the graph we get for this one? Okay, how we get better? Like this you will get. Okay, this is what maximum electric field intensity. Okay, so as everyone know, the k is at 1 by 4 pi epsilon naught. Okay, is it clear? So this is what at smaller. Okay, so this is smaller. Here you have taken the x value. Small r equal to plus r by root 2, we got a maximum, and at minus r by root 2, we got a maximum electric field. Okay, right, beta? Remember this graph. Okay, now note what happens if we pass a charge, that is an electron, on the axis of a circular charge carrying wire. At that time what happens? It performs the simple harmonic motion, beta. Remember this one. Okay, so see here, I'm starting from here. Okay, so I'm starting. Okay, so I'm start with here. Okay, so I'm sending the charge like this now, electron on the axis. Initially the velocity is 0. Okay, now this is a positive charge, electron is a negative charge. What this will do? It will pull this electron towards it, correct? So it is going like this. So while going, its speed is increasing, right? Its speed is goes on increasing. When it reaches at this point, what happens, beta? It becomes maximum, right? What is electric field intensity at the center? It is 0, beta. It is 0. What is electric field intensity at the center? It becomes 0. Okay. See here. So, so I'll tell you one thing. See here. What is electric field intensity due to this arc? Sir, you said the formula na integration wala k lambda by r integration of sin theta d theta. You said x axis y axis. Okay. So for this one, after solving that one, you'll get root 2 k lambda by r. What you'll get? Net. For 90 degrees, you'll get root 2 k lambda by r. Okay. For 90 degrees, you'll get root 2 k lambda by r. Remember this one. Okay. Now, for 180 degrees, what you'll get? Okay. For 180 degrees, what you'll get? So make it in a 2 parts. Okay. So for due to this one, you'll get root 2 k lambda by r. Due to this part, again you'll get root 2 k lambda by r. Na? Right, beta. So these two are again same. The angle between them is what? 90 degrees. If the angle between them is 90 degrees, then answer what you'll get? Okay. Root 2 into, I said you na, the forces formulas. I said you. So I have taught in a different style, beta. So if you know this one, of course you can solve this one numerical within seconds. Within seconds you can solve. Okay. Yes, beta. So see here. Due to this one, you are getting root 2 k lambda bar. Due to this one, root 2 k lambda bar. These two are what? Same. If the electric field intensities are same and the angle between them two is 90 degrees, I given you the formulas na. So then net electric field becomes what? Root 2 E. Root 2 into E. E is what? This one. Root 2 k lambda by R. So final answer is what? 2 k lambda by R. Okay. What is the electric field intensity? Due to this arc 180 degrees making, which is making 180 degrees, 2 k lambda by r, beta. What it is? 2k lambda by r is our final answer. Okay. See here, I've solved this one in 10 seconds, 20 seconds. But if I give it to you, you used to substitute this all the things in the formulas. Na? But the thing is, you have missed my classes. Okay, no problem. So if you find anywhere, so you can go through there. Okay, let it be, let it be. Now see here, in exam, if he ask you, what is the electric field intensity due to this one at center? What will get better? Tell me. Sir, this is the 270 degrees, na? Yes. Now see here, how to calculate? In a simple way, I will tell you. Due to this one, electric field intensity you will be getting in this direction. Due to this one, electric field intensity you will be getting in this direction. Both are same but opposite. Cancel out each other. Okay. So finally, what is left? This one. Due to this one, you will get in this direction. This is what? 90 degrees. For 90 degrees, I said to remember this one. What is that one? Root 2 k lambda by r. Correct? Right, better. So finally, in a circular, sir, this is a completely 360 degrees. I want to calculate the electric field intensity at the center of the circular charged wire. What is the answer? Sir, I will tell you. Okay, so make this one in 4 parts. Due to this one, you will get electric field intensity this turn in this direction. Due to this one, you will get electric field intensity in this direction. Equal but opposite, cancel out each other. Okay, due to this one, electric field intensity in this direction. Due to this one, electric field intensity will be in this direction. Equal but opposite, khatam, cancel out each other. Net electric field intensity is what? 0. It is what? 0, beta. Is it clear? Is it clear for you all? No doubts, na? Very good, beta. Very good, very good. Okay, chal. So when the electron is going like this on the axis, so when it reaches at the center, electric field intensity becomes 0. Okay. Due to the inertia, already it has been gained the large velocity, right? So due to the inertia, it goes forward direction. Okay. So like this, it will be moving in a axis, beta. Okay. So this is what positive charge. That is what negative charge. What this will do, it will pull in this backward direction. While pulling in a backward direction, its speed goes on, decreases. So finally, it becomes rest. After going there, it stopped there. Again, what happens? This is a positive charge. This is a negative charge. It pulls, right? Again, the speed increases. Am I right? Yes, better. So finally, here electric field intensity is 0. Due to the inertia, again it goes forward direction. So like this, it is performing the SHM. See here, speed is increasing, speed is maximum. While it is going here, velocity decreasing, finally 0. While going here, speed is increasing, velocity is maximum. While going here, speed is decreasing, final velocity is 0. Okay, so like this it performs SHM. Electric field intensity due to conducting and non-conducting charge spheres. Okay, right. So conducting sphere, non-conducting sphere. These are the very important beta. Conducting sphere is nothing but the charge is present on the surface. Okay, like a shell. Charge is not present inside this one. Okay, here, but in this case, in non-conducting, charge is present inside as well as outside also. Okay, like laddu, like gulab jam also you can take. Okay, chalo beta. Solid sphere, iron ball. Charge is present inside as well as outside also, beta. Is it clear? Is it clear for you all? Okay, no doubts, na? Maximum have covering the each and every key points. It is sufficient for the JEE, NEET as well as for board also. Okay. Now, see here. What is electric field intensity due to the conducting shell? Outside, outside, outside. Okay. Right. So this is the distance. See here, wherever I am writing the small r, wherever I am writing the small r, that r distance is always considered from the center only. Okay. Of course, this one is always fixed, capital R, radius of sphere. Okay. What is the electric field intensity at this point? Outside, kq by r square. Okay. For this one also. Okay. For this one also, kq by r square. Same formula. No problem. On the surface, small r equal to capital R, na? Kq by capital R square. On the surface, kq by capital R. Same formula. No problem. inside, what is electric field intensity inside the shell? Sir, there is no charge, of course 0. But in this case the electric field is present inside the sphere, right? So what is that value? Kq smaller by r cube, remember. Okay, what is the electric field intensity at the center? Of course 0. Here center, of course 0 only. Okay, the main thing is this formula, you know, correct? Am I right? Kq by r cube. So only one formula you have to remember here. Is it clear? So E is equal to Kq by r square. In which condition we have to use this formula? Okay, so if it is a point charges, you can use Kq by r square. Okay, for a spherical charged bodies also you can use this formula, that is Kq by r square. Is it clear, beta? Sure. Now, so electric field intensity versus small r graph in conducting and non-conducting charge spheres. Now let us see the graphs here, beta. Okay. Acha, see here. Okay. So actually this graph should be here and this graph belongs to this one. So this belongs to this one. Okay, so it went wrong. But here they have mentioned. Okay. See here, beta. Oh, so I can't remove this one also. Okay. See here, this is a very important, beta. 99% he will ask you the graphs only. Okay, he will ask you the graphs only. Please concentrate here. Okay, I have written the formulas here for this body. Okay, for here. The charge is present on the surface. Okay, here. So inside also, na? Here the charge is also present inside. If the charge is present inside, of course, electric field intensity will also present inside. Here there is no charge inside, no electric field intensity. No charge, no electric field. Correct? Yes. See here. Now at the center, electric field intensity is what? This one. No? See here, beta. So you get the graphs are applicable for conducting cylinder also, non-conducting conducting and non-conducting cylinder also, beta. Okay, for conducting cylinder and non-conducting conducting sphere also the same graph will get, same graph. Okay, see here, at center electric field intensity is 0, inside it is also 0, na? So there is no electric field intensity here. Okay, no electric field intensity. On the surface we have. Okay, so like this you will get. Okay, here. After that, electric field intensity is what? Inversely proportional. Correct. So inversely proportional to r square. As everyone know that inversely proportional graph always will get like this. Correct? Okay. Inversely proportional to r square outside. Electric field intensity. Correct? Is it clear, beta? This one is clear, na? So for this one, at center it is 0, na? So at center it is 0. Okay. Now inside, electric field intensity is directly proportional to small r. Directly proportional graph, always straight line, like this. It is inside, directly proportional to small r. Okay. On the surface, this is on the surface, maximum you have. Okay. Now it is what? Inversely proportional. Inversely proportional to r square. Okay. For non-conducting cylinder as well as sphere also. Same graph you will get. Same graph first. Okay. 99% he will ask you this one only. Okay. So many times he asked this one. Okay. Based on the graphs only they have. Okay. Right, beta? So electric field intensity due to hollow and solid cylindrical charged wire. Hollow is nothing but empty. Okay, inside it is empty. Charge is present on the surface. Okay, here charge is present on the surface as well as okay inside also. Yes, chalo, charge is present inside also. Okay, Here inside electric field intensity, do you will get 100% will get, sir. Here you won't get. Okay, so I'll show you the graph also for this one. Okay, so this is what center na. So electric field intensity I am taking here, distance I am taking here. Okay, so what is electric field intensity? See here, these are the formulas. No need of learning. 99% he will ask you the graphs only. Okay, so just identify the graph which belongs to which one. Okay, so he will be giving you the two graphs. Okay, you have to identify it belongs to which one. Okay, now see here, beta. Hollow infinite cylinder. At the center, electric field intensity was 0. Inside, no charge, no electric then. Okay, like this. On the surface, you have something. Okay, on the surface, you have something. Okay, small r equal to capital R. Na? So outside, it is what? Inversely proportional. Inversely proportional graph like this you will get. Correct? So finally, this is the answer. Okay, this is the graph for this one. Next. Okay, in the center, what is electric field intensity? 0. Inside, something you will get. This is a something. Okay, so what you got, beta? This is a directly proportional graphs. Like this you will get. Okay, on the surface, something you have. Something you have. No? Outside, again it is inversely proportional. Outside, inversely proportional. Like this you will get. Okay. Is it clear, beta? Chalo, so this is clear for you all. Okay. Graph. So just now I have drawn the graph na. Just copy paste the graph here. Okay. Motion of a charge in electric field. Okay. So these two are the charge plates I have taken. I am passing the charge from here with velocity v0. It will be coming out from here. So it is making some angle theta. Na? It is coming out with some speed. Okay. From a certain height, y. So he may ask you in question, what is the y value, with what speed it is coming out, with what angle it is coming out. Okay, with what angle the electron is coming out from the field. This is the value. Find the velocity of electron coming out from the field. With what velocity it is coming out? This velocity it is coming out. Okay. Next, motion of charge in electric field. Same. With what height? Y value. So this is a y value, beta. Okay. Chalo. So next, what here? Find minimum velocity of electron such that it exactly comes out from the other edge. Exactly. Okay. So this is a condition he given. So little bit formulas I have written here. You can solve this one by your also. Okay. Based on this one. No need of remembering. According to my guess, 90% you won't get. Okay. Is it clear, beta? So if it is very, very, very important, definitely I will be repeating it for 2 to 3 times. Just concentrate there and put down the star marks there. Okay. Electric dipole and dipole moment. Electric dipole is nothing but there are two positive and there are two charges, equal but opposite charges. Equal but opposite charges are called as dipole. Distance separated by them is 2L. Okay. So this is what? Dipole. Your two equal but opposite charges separated by small distance is called electric dipole. Product of magnitude of charge and the distance separated by them is called as dipole moment. Dipole moment is denoted by symbol P. It is a vector quantity. Remember this one. Okay. So Q formula is Q into 2L. Okay. Chalo. Direction of electric dipole momentum is always taken from negative charge to positive charge. Dipole direction is very important. Negative charge to positive charge. Okay. Electric dipole moment is a vector quantity I have written here. Next, electric field intensity due to dipole along the axis. Negative charge, positive charge. Okay, this is L, this is L. This is what? At this point, let this be the A point. Okay, at this point, you have to calculate the electric field intensity. What is that formula, beta? This one. 2 kp by r cube. 2 kp by r cube. Remember this one. 2 kp by r cube. Okay. And remember one more point. So here the net electric field intensity and the dipole moment direction both are in same direction. Remember here. Okay, the angle between them is theta. He may ask you this one. Okay. Based on you, P is nothing but what? Dipole moment. Formula is what? Q into 2L. Okay, remember, Q into 2L. It is a vector quantity. Okay. Chal. Next, electric field intensity due to dipole along equatorial. Equatorial is nothing but like this. Positive, negative charge, positive charge. This is the origin. This is the length L, and this is the length L. Okay. R distance is always taken from O only. Okay. Equatorial is nothing but this one. Okay. R is always taken from the origin here. Okay. So at this point, you have to calculate the electric field intensity due to this dipole. Okay. So for what you'll get? Equal to Kp by R cube you will get. Okay. This is for the small dipole moments. Okay. If you remember, it is sufficient. Direct formula he may ask you. Direct formula. Now, here, electric field will be in this direction and the dipole will be in this direction. The angle, what is the angle between these two? He may ask you. You have to tell they are in opposite direction. Theta is 180 degrees. Okay. Electric field intensity due to dipole at any point in space. Now, whatever the angle he may give, easily you can calculate. Easily you can calculate. Okay, at this point you have to calculate. Okay, electric field intensity. Let this is the angle theta and this distance is R. I said you now. Okay, the R is always taken from. Okay, the R distance is always taken from the origin O. Okay, at this point you have to find out what is the formula. This one. Kp by R cube under root of 3 cos square theta plus 1. Remember, he may give you any angle. If you substitute that angle value here, you will get the answer. Okay, torque on electric dipole. When you keep a dipole on in an electric field by making some angle theta, what happens? Of course, it will be rotating like this, right? So, torque formula, turning effects. Remember this one, 100% you have to remember, beta. Very, 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 very important it is. Okay, right. So, cross product numerical. If you know the cross product numerical, how to solve, how to identify, how to check out the direction, what is its rule. If you know these points, khatam, you can solve every cross product numerical within second. There is a best trick, beta. Okay, to calculate the cross product numerical and how to identify. Okay, chalo. See here, these are the key points, remember. So this is applicable for from kg to PhD. Okay, in all cross product numerical it will be applicable. First one, cross product formula, how it is, as it is you have to by heart. Don't write down this E here, P here. Okay, don't interchange them. First you have to write down P, next only E. Sir, how to remember? Potential energy, PE, potential energy. Trick is, okay, it is a cross product, 100% all should be perpendicular. Torque R and F should be torque P and E should be perpendicular to each other. Okay, if they are not perpendicular, make them perpendicular by using the components. Rule is right hand thumb rule. Fingers P to E. Okay, thumb indicate what? Direction of the torque. So if you are unable to understand this one, so really I am very disappointing to me, because already you have solved so many numericals on this one. Already you have learned vectors, na? So actually I have my own trick to solve this one. Okay, if you know that one, so it will be very easy, beta. Okay, while I am teaching the cross product numericals or anywhere, okay, in any chapter, if you get a cross product numerical, definitely has to focus this point to the students, beta. Okay, because this plays a very important role. Once if you analyze this one perfectly, definitely you are able to solve. Based on this rule, there is one chapter, electromagnetic induction. If you know this rule, you can solve that one within a year. Very easy, beta, very easy. Okay. Thumb indicate what? Direction of torque. Note, if you forgot this, hit your head with your hands like this. Okay, why I have forgotten this one? Why I have forgotten this one? Okay, hit here. But don't forget this one beta, because abba, very, 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 very infinite times important. Okay, these points are the important, because if you know these points, you can solve any type of numericals in physics, complete physics. Okay, chalo. So in all cases, if theta equal 90 degrees, you get this one. Okay, just torque formula is what? P sin theta you got. Na? If theta is present, you'll get sin theta only. Okay, theta is the angle between P and E. Okay, put theta value 90 degrees, 270 degrees, and 0 degrees, and 180 degrees. Okay, if it is 0 degrees, torque will be become 0. It is called as stable equilibrium. Okay, if theta is 180 degrees, it is called as unstable equilibrium. Okay, P and E both are in opposite direction. Here, P same direction. Here 90 degrees. Okay, electric field P 270 again like this. Okay, chalo. So these are the cases easily you can identify. Potential energy of an electric dipole. Okay, so while rotating, some amount of energy will be stored here. Okay, due to that stored energy, it was unable to rotate. Why the dipole is not rotating in electric field? Because there is some energy stored. That energy stored is our potential energy. What's the formula? It is a dot product. Remember, dot product. Okay. So 100% you have to remember this one. I said you the trick for solving the dot product numericals also. Whatever it may be, any formula you can solve this one with the best trick beta. Okay. See here. So finally, if theta is present between these two, minus P cos theta. So how to remember this one? I'll tell you. Okay. So just integrate the torque. Okay. If you integrate this torque, P is sin theta. Na? Just doing integration, you'll get this one, potential energy. Okay. Remember this one. Again, next are the cases. Just I have written the cases here. Just go through this one. Okay. Remember this one. Okay. Because while solving the numericals, it will be helpful for you. Electric flux. Formula is what? It is denoted by symbol pi, and the formula is EA cos theta. Okay, the electric field lines are going like this. This is the area of cross section. Okay, what is the flux? For electric flux, 100% you need a like this surface. You need a surface area. Okay, electric flux is a scalar quantity. SI units are volts per meter. Okay, see here. This is A, and the electric field is going like this. Okay, the angle between them is theta. Now what we have to do? What is the flux? How we will take? Formula is what? EA cos theta. Na? So wherever theta is present, there you will get cos theta. Na? So here is what? E cos theta. I have taken the component. So finally, what is the answer? You got E cos theta into A. Okay, so like this, there are so many tricks. Okay, if you know this one, it is very easy. So I have explained in a different style. Okay, in which method I am explaining you, I will be telling you in the tricks in that method only for you. Okay, so this is clear for you all now, beta? Right. So electric flux. Whenever for a closed bodies, normal, for a closed bodies, the normal is always taken outwards, beta. Remember this one. Okay. The number of flux entering is equal to the number of flux coming out. At that time, net flux becomes 0 beta. See here, from cube, the flux is entering and coming out same, entering and coming out same, entering and coming out same. Net flux becomes what? 0. Remember, because flux is a scalar quantity. Gauss law, it is defined as the total electric flux coming out from a closed surface is 1 by epsilon naught times of the charge enclosed in it. This one is important for the board. You will get for 2 marks. Okay, write down this formula. So as everyone know that this is a flux is equal to integration of E into dA, charge present inside the body. Okay, what is the use of this one? Based on this one, based on the flux also, you have so many numericals you got in NEET exam, JEE mains exam. Based on these applications also, you got so many numericals beta. Okay, just remember the formula. This is actually used to find out the electric field intensity of any bodies. Okay, So to apply this one 100%, remember, to apply Gauss law 100%, there should be a closed loop. Okay. Now I am giving a charge for you, keeping here. So at this distance, at this point, find electric field. How? Sir, this is not closed now. How we can find out? What you have to do is take this charge, keep it in your mouth like this. Now it become a closed na. So this closed Wallah is called as what? Gaussian surface. What this one is called? Gaussian surface. So here you can apply. Okay, now see here, integration of E into dA. Okay, E into dA is equal to, what is the charge present inside the Gaussian surface? Q by, okay, Q by epsilon naught. From Gauss law I am taking, okay, these two I am comparing. Chalo, E into, what is the surface area of a sphere? 4 pi r square, Q by epsilon naught. E is equal to, what you got? Q by 4 pi epsilon naught r square. 1 by 4 pi epsilon naught is what? K. Kq by r square. Like this, so many we have. Hence proof na. What is the electric field intensity at this point? Kq by r square only na. We got. Okay. So many applications we have. Just practice these applications. Okay. And solve some numericals. If you remember this one, it is sufficient. Okay. While solving the numericals better. Okay. So thank you so much. So I hope you have enjoyed the class. And the points I have taken again, I am again repeating. Whatever the key points I have taken, these are the important for JEE, NEET as well as board exam also. Okay. So just do the revision of this one regularly. Okay. So do the revision today, and in the next day also again you have to do this one revision, and the third day also again you have to do this revision. Even if you know also, again do the revision. Okay. Till the NEET exam or JEE or board exam. Okay. Till the last day you have to daily do the revision beta. Then 100% you will be remembering all the formulas. Then you are going to rock the exam. Okay. Thank you so much. Let us continue in the next class. Bye beta.